Hello. Welcome back, everybody. I'm Griffin. This is brilliant.org. We're going to be solving more trigonometric function problems in this episode. Let's dive right in. Alright, so for this first problem, we have cosine to the fourth plus sine to the fourth plus 3 sine squared times cosine squared all over cosine to the sixth plus sine to the sixth plus 4 times sine squared times cosine squared. All right, and all of these are to the degree of 75 degrees. So let's dive right into this problem. All right, so what am I thinking right now? Well, I'm noticing that our fraction is kind of divided into two parts. We have these sum of high powers, the numerators to the fourth, denominators to the sixth. And then the right side of our equation, we have pretty similar things. We have 3 sine squared times cosine squared on the top, and then 4 sine squared cosine squared on the bottom. So this is going to be a lot to write down. So I'm gonna let sine of x, I'm gonna just write this as s, and I'm gonna write cosine of x. I'm just going to write this as c. So whenever I'm solving problems like this, I like to have all the powers be the same. So I'm going to start with this term, and I'm going to try to make it match the numerator as much as possible. I'm going to try to change these 6's to a 4's and see how that works out. So let's get started doing that. So what do I have? Well, I have cosine to the sixth plus sine to the sixth. What does this equal? Okay, well, we could have a cosine to the fourth plus a sine to the fourth times a cosine squared plus a sine squared. And this would work, except we're going to have two middle terms we're going to have to cancel out, right? And what are we going to have to cancel out? Well, we need to subtract a sine to the fourth cosine squared from the sine to the fourth times the cosine squared, and then we're going to need to subtract a cosine to the fourth times a sine squared. All right, that looks good so far. What do we have here? Well, this term, cosine squared plus sine squared, well, there's a Pythagorean identity that says cosine squared plus sine squared equals 1. So this term is going to cancel out to be 1. And then here, we have a difference of 2 squares, and we can actually factor out. What can we factor out? Well, we can factor out a sine squared and a cosine squared, and we will be left with sine squared plus cosine squared. And this, again, this is Pythagorean's identities, and so we can cancel this out because it's going to be a 1. So what are we left with? We are left with cosine to the sixth plus sine to the sixth. This must equal cosine to the fourth plus sine to the fourth minus sine squared cosine squared. All right, that looks pretty good. Let's go back to our let's erase, clear up some space. Let's look back at what we have. Well, looky here. This minus sine squared cosine squared, we can just subtract it from this term, the 4 sine squared cosine squared, and whenever we subtract it, it's going to change to a 3 sine squared cosine squared. And now it matches the numerator. That's rather nifty. And what's left? We have our cosine to the fourth plus sine to the fourth. Cosine to the fourth plus sine to the fourth plus 3 sine squared cosine squared. So look at that. Our numerator and our denominator are the same, so that means they must divide to be 1. Awesome. this is great. I love problems like this that simplify down, and the answer is something as simple as 1. This problem looks so complicated, but just knowing a very basic trigonomic identity and simplifying the 6th power down I just see so much beauty in this problem. All right, let's continue on to the next problem. What do we have? We have minus sine squared of 1 plus sine squared 2 minus sine squared 3 plus etc., all the way through sine squared 90. All right. So let's think about this. Let's draw a unit circle and think about this for a little bit. We have our unit circle. We're starting here. Let's get the line tool out. We're starting just at the 1st degree, and then we're going to go all the way up, adding and subtracting the square terms all the way to sine of 90. So we're really just looking at this first quadrant. And then what else do we have? Okay, so we're subtracting sine squared of 1, adding sine squared of 2. So usually the key to solving problems like this is some rearrangement of the order. And there is definitely a relationship between sine and cosine. I know that sine of x equals cosine of 90 minus x. And can this be useful? This will be a handy symmetry. If we started at 0, sine of 0 degrees, I would pair it with the sine of 90, but let's just cut this one off for a minute. I can pair the minus sine squared of 1 and the minus sine squared of 89. And then from this property, the sine x equals cosine of 90 minus x, what do I have? I have minus sine squared of 1 minus cosine squared of 90 minus 89, which is 1. All right, and then what is this? Well, we can factor out a minus sign, and we're left with minus sine squared plus cosine squared, and so this must be negative 1. Oh, so this is how things are going to cancel. Very nice. Okay, let's clear our board. Let's make room. So what did we just find out? We saw that the minus sine squared of 1 and the minus sine squared of 89, which we're going to change to what? We're going to change it to cosine squared of 1. These will pair and give us a minus 1. And then the sine squared of 2 and the sine squared of 88 are going to pair together. And these are both positive, so this is going to be a positive 1. And so this is going to continue on. So we see a minus 1 and a plus 1. These are going to cancel out to just be 0. So what doesn't cancel out? Well, our centermost term that's not going to cancel out because it's not going to have a pair is going to be sine squared of 45 degrees. And then this last term didn't get used either. So we're going to be adding sine squared of 90. And let's wait one more second. Is our sine squared of 45 going to be positive or negative? Okay, this is going to be minus sine squared of 3 degrees. Yeah, so this is going to be a minus sine squared of 45. All right, so now that so this is easy to solve now. So what is sine of 45? Sine of 45 is root 2 over 2, and we're going to square this, and then we're going to add sine of 90, and sine of 90 is 1 squared. So what do we have now? We have 2 over 4. So we have minus a half plus 1, well, this equals positive 1/2. So our answer here is A. Awesome. This was a fun problem too, just doing some maneuvering, getting to this answer. That's great. That's great. Let's continue on. What does this problem say? All right, so we need to know about logarithms and tangent for this problem. So what's happening here? What is happening here? Okay, well, what does the problem even say? It's asking for the product of, and this is just a symbol for a chain of products, capital Pi, that is. And we'll say n equals 1 to n equals 89, and this is of log tan of n. So this is what the problem is saying. What do I know about tangent? Well, I know tangent is sine over cosine. Okay. And what do I know about logarithms? Why is the logarithm going to come in handy? And this is specifically log base 10. Okay, pretty much the most common log other than the natural log. So we know log of, well, what's gonna, oh, okay, so what is log of 1? Log of 1 equals 0, right? Because what is logarithms is saying 10 to what power x equals 1, 10 to the 0th power equals 1. So whenever tangent, when does tangent equal 1? Tangent equals 1 whenever sine equals cosine. And when does sine equal cosine? It equals sine equals cosine. Well, let's clear the board. When does sine equal cosine? We know this. Let's look at our unit circle. Sine equals cosine at 45 degrees, right? At 45 degrees, we have root 2 over 2 and root 2 over 2. So this is saying tangent at 45 equals 1, and log of 1 equals 0, and this is a product, and anything times 0 is 0, so our answer must be 0. Excellent. All right. You know, a curious thing about, mathematics and physics and all this stuff, especially in physics, is, nature has a kind of sort of symmetry to it, and 0 is really the most common answer on a physics test. It really is. Just because nature tends towards equilibrium, and so there's a little tidbit for you. If you ever are wondering what to write down on a physics test, just write down 0 and you might get it right. All right, what's our next problem? Let's see. All of the above 4 numbers are negative except for which one? Okay, well this one's a little bit too easy. If you know your unit circle, so let's think about it. If we know our unit circle, cosine, our unit circle is always written in what? Cosine, comma sine. So cosine is our x value. So anything in the second and third quadrant is going to have a negative cosine. And these are all written in radians, right? So this is 0, and then it's pi over 2, then it's pi, then it's this is 3 pi over 2, and then 2 pi, right? So cosine of 2 pi is 0, so it's not negative. So that's going to be our answer. 2 pi over 3, it's going to be over here, 3 pi over 4, again over here, 4 pi over 5, again over here. So cosine of pi over 2 is our answer. It is not negative. Excellent. Let's see what our last problem is. All right. This one seems interesting. An ant finds itself trapped in the xy plane, and its initial position is coordinate 1, 0. Let S sub k denote the circle with radius k centered around the origin. Starting from point 1, 0, the ant walks 1 unit counterclockwise on S sub 1. Then it walks directly, radially outward to S sub 2, on which it will walk 2 units counterclockwise. This pattern continues with the ant walking k units on S sub k. When the ant crosses the positive x-axis for the first time since it left 1, 0, it is on S sub n. What is n? Okay. So I hope you followed what I was saying, but if you didn't, it's saying the ant is starting at this position. It walks 1 unit, and then it radially goes outward to S sub 2. It will go 2 units, then go up 3 units. It'll go out 4 units, out 5 units, out 6 units, out 7 units, etc. And so when does it cross the positive x-axis? That's the question. When will it cross the x-axis over here? So how can we figure this problem out? What do we need to be thinking? Well, what do we know about circles? And what do we know about going around a circle radially, and what problems are we solving? We're solving trigonometric problems. Okay, I'm thinking a 360 degrees circle. Okay, it uses the word radial in the question. So let's think about this in radians. How many radians is 360 degrees? Well, we need to do what? We need to multiply by pi and divide by 180 to find this in radians. And this equals 2 pi. So we know that, yeah, a circle is 2 pi radians. And each time the ant is walking a total of 1 radian each time, right? It's walking 1 radian here, and then it goes outward to a unit 2 circle, and it walks a distance of 2, and then it goes out to a unit 3 circle and goes 3. So each time this ant is walking 1 radian. And how many radians are in a circle? Well, 2 pi. What is 2 pi? Well, it's approximately 2 times 3.14, which is 6.28. So the ant will finally cross this positive x-axis whenever it's on the 7th circle. So S sub n must equal 7. That's my answer. I'm sticking with it. Let's check it out. 7. Oh, put 8. 7? Correct. Excellent. Excellent. This was a really fun problem set. I hope you guys enjoyed. I hope you learned something about how to problem solve. Let me know what you think in the comments down below. Thanks so much for watching. If you haven't already, please subscribe to my channel. Until next time. See you guys.